In this video, we're going to be reviewing how to graph quadratic functions. You've done this before, so again, this should be a quick review because we're going to graph some other functions, and we just want to, like I said, refresh your memory. We've been solving quadratic functions or equations, and so we want to make sure that you can still graph them. All right, so please remember that a quadratic function or quadratic equation, remember that's x squared is the highest power. That creates that U-shaped graph that we call a parabola. All right, parabola or parabola, okay? And remember that means it has like a high or low point. That's the vertex, okay? But in this review, we're going to extend that just a little bit and talk about the fact that when it opens up, that vertex, right, is actually a low point. And so sometimes we'll refer to that as a minimum. All right, and so when you practice this, that is one thing that you're going to have to be able to tell me now, is that that vertex is in fact a minimum, or if it opens down, that vertex will be a maximum. Okay, all right. We have looked at two different forms of quadratic functions or quadratic equations. One of them was in vertex form. All right, so that looked like this, where you had a times x minus h squared plus k. All right, where remember your the h value told you your left or right shift, and your k value told you your up and down shift, and that made it very easy to get the vertex. A also told you if it was positive, the parabola would open up. If it was negative, the parabola would open down. You could also get your, vertical stretches or shrinks out of that. Standard form is the form that we've been working with the most when we were solving, okay? Because you could either factor it or use the quadratic formula to solve it. Vertex form is what we were typically using if we got to use square roots to solve. All right, and so then we just want to review real quick how to graph these things. We're going to use Desmos. So you're just going to type the function in Desmos and you're just going to look at it. Does it open up or down? All right, then you're going to find the vertex and you're going to be asked to tell me if that's a maximum or a minimum. Then you're going to find the x-intercepts. Well, how does that relate to our solving? Well, remember the solutions are the same thing as the x-intercepts. And when we did it before, we called them zeros because, again, that's what makes the equation equal 0, which is also what makes an x-intercept or a solution. So finding the x-intercepts is the same thing as finding the zeros, the roots, or the solutions. All right, keep in mind that a quadratic function can have two x-intercepts, and I'll just show up parabolas for this. But of course, these could also be down parabolas. All right, but we could have two x-intercepts. It is possible to have just one x-intercept. I know that was really bad, but I was trying to just touch the x-axis one time. And then, of course, it is possible that we have no x-intercepts. All right, well, how does that relate to our solutions that we were finding before? Two x-intercepts is the same thing as having two real solutions, whether they're rational or irrational. One x-intercept is the same thing as having one real solution. And no x-intercepts is the same thing as having no real solutions, but then that would mean it would have two complex solutions. So the number of x-intercepts tells you how many real solutions the quadratic function has. And if the quadratic function has no x-intercepts, that just means it has two complex solutions, and that is not something that you can find just by looking at the graph. That is something where you would have to actually use the quadratic formula to find those values if you were asked to. Okay, then you're going to be asked to find the y-intercept, use all of that information to draw a graph, and then you're going to be asked to find the domain and range and end behavior and intervals of increasing and decreasing. So we're going to review all of that on the next slide. Okay, so here's my first graph. And what I want to do is I'm going to pause my video real quick so I can split my. Okay, so here you see that I have my screen split between the worksheet or the notes and Desmos. And that's because the first thing I want to do is come over to Desmos and type my function in. All right, so you're welcome to do f of x equals, you can do y equals. In fact, you actually don't need to do any of that. You can just do the parenthesis, x plus 4, close parenthesis, square it, minus 4. Okay, and then what I would probably do, since I'm splitting my screen, is I'm going to lower that. I'm going to slide that out of the way. And then you can, on your screen, you should be able to click on your graph, and then you should have a bunch of gray dots that you can click on. And then we're going to have to slide it down to find this one up here. Okay, so we'll come back to that one in a minute. All right, so now we're going to go over to our notes, and we're going to fill everything in. All right, so I want to know if this opens up or down. Well, hopefully you can see that that definitely opens up. The vertex is at -4, -4. And because it is a low point, it is at the bottom of that parabola, we call that a minimum, and we can just do min for short. All right, and then I want to know how many real solutions this thing has. Well, that's really the same thing as how many x-intercepts does this graph have, and you can see that it has 2, and then we're going to write them down. -6, 0, and -2, 0, and then we have to slide our graph around a little bit to find our y-intercept. It's all the way up here at 0, 12. Okay, once you have all of that information, you really can kind of set Desmos to the side for a minute and then come back over here and actually use that information to make a graph. So I'm going to go to -4, -4, put my vertex, and then I'm going to go to -6, 0, and -2, 0. And then I know it's going to be off a little bit on my paper, but 0, 12 would be up there. Now, to keep it symmetric, right, in terms of x values, 0 is 2 away from this point. And so if I go 2 away from that point over there and go up to 12, I could actually put a symmetric point, because remember, ooh, that's not good. Parabolas are symmetric. So this is going to be really hard for me with my little sketching tool here. All right, I know that looks kind of, I'll go back and see if we can make this. Whoa. This is really hard with my little tool here. Let's see if we can make that a little bit better. Okay, and then of course I want to come down here and I want to make this a little bit more curved. Wow, this is really hard with my little gadget here. Okay, so there's our parabola. Again, make sure that doesn't look like a sharp point. All right, now let's review how to find the domain and range. Okay, well, remember the domain are the x's, so you look at your graph from left to right. Okay, well, so this is the left end, and yes, it's going up, but it's also pointing to the left, all right, forever. And this side is the right, and yes, it's going up, but it's also pointing to the right forever. So if you remember, the domain for all quadratic functions is the all real numbers, -infinity to +infinity. It's the range that's going to be affected when you have a parabola. So remember, for the range, you're looking at the y values, and you're working your way up the graph from bottom to top. And so as you come up, the first point you get to that's on the graph is the vertex. So that means your range is going to start at the vertex, and you need the y value, and then your graph goes up to +infinity from the vertex. Okay, so there's your range. All right, then we need to review end behavior. Well, remember the end behavior, okay, for the x's is asking you to look at the right and the left. Now, because I have an arrow on the right and the left, I need to have some sort of infinity next to each one of these x's. So I'm going to use a negative infinity to talk about the left, and I would use a positive infinity to talk about the right. Okay? Then when I fill in for the y values, okay, whoop, I meant to change colors. All right, you are looking for whether the arrows are pointing up or down. Okay, now both of these arrows are pointing up. So for up, we use positive infinities. Okay, so hopefully you remember that. And then for increasing and decreasing, you're literally going to trace the graph from left to right. So you start on the left and you trace, and it's going down first. I know this is a really bad trace. All right, so we're decreasing first and increasing second, and it changes at the vertex. Make sure you use the x value of the vertex. Okay, and so we're decreasing from the left, which starts at negative infinity, and we decrease until we get to the vertex, and the x value is -4. Then we increase from the vertex to the right forever. So remember, we've done this before. You just figure out which one's happening first, and next to that word, increasing or decreasing, you start with negative infinity, and you stop at the vertex. Then whatever one happens second, you start again at the vertex, and you always put positive infinity with that one, okay? Because we're talking about left and right, not up and down. All right, let's try another one. All right, and this would probably be a good time for you, because this is review, to type this in Desmos yourself, okay? And then try these things out on your own, okay? All right, so let me see. Let me pause it so I can split my screen. Okay, so for number 2 here, we're going to go over to Desmos, and I don't want to write. I'll use my mouse here. I'm going to do 3x squared plus 1. I'll get rid of the, whoops, wrong thing. Let me undo that. Just want to slide this over and maybe make that a little bit bigger. Okay, so you can see that you have a vertex at 0, 1, and then you can kind of slide it around, and hopefully you notice you don't have anything else. Okay, so go back over to your worksheet here or your notes, and we're going to talk about whether this thing opens up or down. Hopefully you can see that it opens up. You can see that the vertex is at 0, 1. And so that is in fact a low point. So that is a minimum, right? And remember, the real solutions are the same thing as the x-intercepts. I don't know about you, but I don't see any x-intercepts. So then how many real solutions do we have? None. 0. Okay? That would mean we have 2 complex solutions, and that's something that Desmos can't show you the answers for. Okay? 0, 1 is also our y-intercept. And so now we can set Desmos aside and fill in everything else by graphing. So I'm going to go to 0, 1, and I'm going to draw an up parabola. Now, I could actually use Desmos to try to find a few other nice points, but this is just a sketch, so we're going to do it best we can there. And then hopefully, you know, because it's quadratic, you remember the domain is negative infinity to positive infinity. Again, this one opens up. So for my range, the first y value I get to is the vertex, and it goes up from there. We still have a left end and a right, whoop, and a right end. Sorry, so left is negative infinity, right is positive infinity. It does not matter which one you do first. Excuse me. And then if you look, both ends are pointing up, so we're going to use positive infinities for that. Okay? And then when we trace from left to right, we're going down first. So we're going to start on the decreasing line with negative infinity. And we're going to stop when we get to the vertex, but you need the x value of the vertex. okay? Then the increasing just starts at the vertex and goes to positive infinity, okay? So hopefully you did that one on your own and then checked with mine. All right, and then last but not least, let's look at one that has a negative x squared. All right, so again, nope, that's not what I want. I want to split my screen here. Okay, and let's type in negative x squared minus 2x minus 1. Okay, get rid of that, slide that to the side. All right, and notice we only have a few points to click on, but we can tell that this thing opens down. We can tell that the vertex is at -1, 0. And so because it opens down, that vertex is at the top of a hill, so we call that a max. And it is the only time it crosses the x-axis. So it is the x-intercept, and that means there is only one real solution. Okay, there is a y-intercept that we can see at 0, -1. And then we can slide Desmos out of the way so we can answer the rest of our questions. All right, so we need to go to -1, 0 for our vertex and 0, -1 for our y-intercept. And then sketch our graph. Okay, our domain, -infinity to +infinity, all real numbers. All right, this time, as we work our way from bottom to top for the range, we're starting with arrows that are pointing down. So that means our range is starting at -infinity and then stopping when we get to our vertex. And that is a close point, so we're going to use a bracket. Okay? For our end behavior, we still have a right and a left, or actually left and then right. So you still need one -infinity next to an x and one +infinity next to an x. Okay? Now, both of these are pointing down. So when we talk about what the y is going to, all right, they're both going to -infinity because they're going down. And then when I do my intervals of increasing and decreasing, remember you start on the left and trace. So we're going up first, we're increasing first. So you always start at -infinity, stop at the x value of the vertex, and then we're decreasing second. So we start at the x value that we just left off on, and we always go to +infinity. Okay? So hopefully you remember all of that stuff, and that was just a quick review for you. And then there will be 3 practice problems for homework. All right, see you next time.